I have some example problems here from our equivalent vectors exercise on Khan Academy. So let's go through these. And like always, pause the video and see if you could work through them on your own. So this first one, it says, are vectors u and vector w equivalent? And so we can see vector u here in blue and vector w right over here. And we have to remember, a vector is defined by both having a magnitude and a direction. And so for two vectors to be equivalent, they have to have the same magnitude and the same direction. So when I look at these two, they are clearly pointing in different directions. Vector u is pointing to the bottom right, that's the direction it's pointing in, and vector w is pointing to the bottom left. So they definitely are not equivalent. So they are not equivalent. Scratch that out. So they have different directions. And let's think about the magnitude. If I just look at the length of the arrows, just eyeballing it, they look pretty close. Let me verify that. So if I'm starting at the initial point for vector u, how much do I move in the x direction? Well, in the x direction, I go from, -8 to -3. So I could say my change in x is +5. My x increases by 5 as I go from the initial point, from the x coordinate of the initial point to the x coordinate of the terminal point. So that length, the magnitude of just the x component is 5. And let's see what happens in the y direction. So in the y direction, I start at y equals -2 right over here. And then I go down to y equals -8. So my change in y is equal to -6. Now let's think about this one over here. What's my change in x? Well, I'm starting at x equals 8, and I am going to x equals 3. So my change in x is -5. Let me write that. Change in x is equal to, this is my change in x. And then what's my change in y? Well, I start at y is equal to 8, and I go down to y is equal to 2. So do it just like that. So my change in y is equal to -6. Now, based on the changes in x's and y's, I can figure out the magnitude of each of these vectors. The magnitude of u, so I could write it like this. The magnitude of u, sometimes you'll see the notation like this. The magnitude of u, of vector u, I should say, is going to be equal to, we're just going to use the Pythagorean theorem here. It's going to be the square root. The length of this arrow is just the hypotenuse of the right triangle. So it's going to be the square root of 5 squared plus -6 squared. So it's going to be the square root of 25 plus 36, which is equal to the square root of, what is that? It's going to be 60, square root of 61. I can make that radical a little bit smaller. Square root of 61. Now what about vector w? So the magnitude of vector w is, I could use those double bars. The magnitude of vector w, well, that's going to be the square root of -5 squared, which is 25, plus -6 squared, which is going to be 36. Well, that's going to be the square root of 61 as well. So they have the same magnitude, just different directions. So let's see. No, they have the same magnitude, but different directions. Yep, that's the choice we like. Let's do one more of these. Are vectors u and w equivalent? All right. So these look pretty equivalent, just eyeballing it. It looks like they're pointed in the same direction. They're going from the bottom left to the top right. It looks like they're the same length, but we can verify that once again by looking at their x and y components. So in the x direction, or thinking about how much we change in x and change in y when we go from the initial point to the terminal point. So in the x direction, for vector u, we go from -7 to -4. So we increased by 3. And what do we do over here? We go from x equals 2 to x equals 5. So our x component, once again, has a magnitude of 3. Our change in x is a positive 3. And so our change in y, what is that going to be? Well, we're going on this vector from y equals, whoops, I'm using the wrong. We're going from y is equal to 1 to y is equal to 6. So the magnitude of the y component, we can say, is 5, or our change in y is a positive 5. And then the change in y over here also is a positive 5. We go from negative 7 to negative 2. It's also a positive 5. So notice our change in x is the same. It's a positive 3. Our change in y is the same, positive 5. So that lets us know that we have the same magnitude and direction. And so these are equivalent. These are equivalent vectors. And in fact, as we'll see in the future, you can actually denote a vector by its components. We could say that vector u is the vector the vector 3, 5. Our change in x, our change in y. And that is exactly the same as vector w. So that is exactly the same as vector w. It has the same change in x, same change as y as we go from the initial point to the tip of the arrow, the terminal point.